Right. So we are starting the new session, new unit, that's a relational database systems, and there are three learning outcomes. The first learning outcome, which we will discuss today, is understanding the database management system. The unit name is Relational Database Management System, and first we discuss the database management systems. A DBMS, a database management system overview. We start from the database first. Database is a collection of related data, and data is a collection of facts and figures that can be processed to produce information. So you have a data, and when it is processed, it becomes information. When you say 2 is a number, that's a data only. But when you say that there are 2 people going to abroad, then it becomes an information. You have 2 cars at your home, then it is an information. Mostly data represents recordable facts. Data aids in producing information which is based on fact. For example, if we have a data about marks obtained by all students, we can then conclude about toppers and average markers. A database management system is a software that allows creation, definition, and manipulation of the database. So any data which you have in the form of process form, that becomes information, and information, the bunches of information becomes the database. And database management system is basically a software that allows you to create, define, and manipulate the database. And databases can be said as a bunches of the data, and obviously that is the information. DBMS is actually a tool used to perform any kind of operation on the data in a database. DBMS also provides protection and security to database. So if you have a data simply, then it cannot be managed, created, manipulated easily, but it is the role of the database management system to give you all the operations of the features for all operations on the data, as well as its responsibility is to give you the protection to the data as well as security to the data. It maintains data consistency in case of multiple users. Here are some examples of the popular database management systems: MySQL, Oracle, Sysbase, Microsoft Access, IBM DB2. There are lots of database management systems available. Overview again. Characteristics of a database management system. It's a real-world entity. A modern database management system is more realistic and uses real-world entities to design its architecture. So database management systems are nowadays used realistically, can be used for any kind of domain. A relational database tables is a form of database which allows entities and relations among them in the form of tables. If you have a tabular data in the rows and columns defined, it is basically the relational database system. It gives you isolation of data and application. A database system is entirely different than its data. It's most important to note that if you have a database management system, then your data is kept entirely separate from the database management system software itself. There you won't get a mix-up of it. Less redundancy. Database management systems follow the rules of normalization, which splits a relation when any of its attributes is having redundancy in the values. Redundancy is the duplication of the values, reoccurrence of the values, but then you have number of uh, when you have a data available in more than one tables, then possibly you might be repeating the data into same tables and into different tables. So using the database management system, it allows you to reduce the redundancy into the data using normalization techniques. Consistency is the state where every relation in a database remains consistent. There exist methods and techniques which can detect attempt of leaving database in inconsistent state. So consistency basically gives you a permanent state of the database, which allows you to store a commit the or whatever you retrieve the data, whatever you save the data, it gives you a consistent state. Once you store the data, it becomes consistent. Querying language. Database management system is equipped with a query language which makes it more efficient to retrieve and manipulate the data. You have a database management system, you can view, insert, update, delete your data as a front end view of the information and of the data in a database management system, but it's not necessary that every time you only look up the whole view of a particular data or record or table, but you require sometime you need to query a database to ask a particular information, a record in a particular way, for particular purpose, for particular range, for particular type. Then basically you query a database, and a query language, you for particular querying you used the query language, which is mostly the structured query language used in the database management systems that we will be discussing in next slides. Multi-user and concurrent access. The database management systems allow you to access the database. It is the beautification of the database system that it could be accessed by the multiple users and many users accessing the same time. It is also the feature. So you have one possibility that multiple users can access the data, as well as they can also access the same data to be shared by everyone. That's a feature. So database management system supports multi-user environment and allows them to access and manipulate data in parallel. So there won't be any problem of the inconsistency. There will not occur any inconsistency or problems while the data is being accessed by many users at one time. For example, if you want to view the item description, then the item description could be accessed by many users. And for example, if 10 users wanted to place an order at one time, that is also possible, that the database will not be affected and all the purchases of 10 customers, and no matter they place the order at exact same time, but the stock will be automatically updated and will be updated, without any problem. For example, if there are 10 items and 10 people placed the item in their basket, and 10 out of 10 they paid at one time, then what do you expect that how the item will be reduced from the database? It shouldn't be the case. There won't be any problem. The database management system would give you a consistent access without any problem. Users of the database management system, there are the administrators. Administrators maintain the database management systems and are responsible for administrating the database. They are responsible to look after its usage and by whom it should be used. So they not only use by themselves, but they also define who can use the database management system. They create access profiles for users and apply limitations to maintain isolation and force securities. The designers are the group of people who actually work on the designing part of the database. So administrators, they maintain by themselves as well as they create the roles, the users for the usage of the database management systems by the other users. The designers, they design the designing part of the database, and end users are those who actually reap the benefit of having a database management system. The end users can range from simple viewers who pay attention to the logs or market rates to sophisticated users such as business analysts. So the end users can be any. It could be any simple user, or it could be any market analyst, business analyst, which can get a benefit from the database. Types of database management systems. There are 4 structural types of database management system. One is the hierarchical database, other one is the network databases, relational databases, object-oriented databases. Hierarchical databases model is a data model in which data is organized into a tree-like structure like this. The data is stored as records which are connected to one another through links. A record is a collection of fields with each field containing only one value. The hierarchical database model mandates that each child record has only one parent, whereas each parent record can have one or more childs. So here is a record in each field. Here are more than one children, and like pavement improvement, reconstruction, maintenance, rehabilitation, routine, corrective, and preventive. So children, a parent can have more children, but one children can only have one parent. So basically this is kind of the structure. It's not necessary that you use every time a similar structure, but in some situations, like scientifically or technically, you might require a different structure to maintain a different kind of the nature of the data. So hierarchical is one of them when you really need the particular type of data. Network database. A network database model is a database model. Basically, if you take an example of Facebook friends, like in Facebook, a friend is connected to a friend, and another friend is connected to another friend. Sometimes you get a mutual friends, sometimes you don't look at the friends, and that hierarchy basically is taking you to different levels. So all kinds of models, the complexities exist into the nature of the data. Whichever suits to a particular model, then particular type of relation or data is stored into the database. The network is one of them. A network database model is a database model that allows multiple records to be linked to the same owner file. The model can be seen as an upside down tree where the branches are the member information linked to the owner, which is the bottom of the tree, the multiple linkages, which this information allows the network database model to be very flexible. In addition, the relationship that the information has the network database model is defined as many to many relationship because owner of the file can be linked to any member files and vice versa. So here, like one sales representative is connected with an invoice. An invoice is basically connected with many customers or many payments and many invoice line, and one product has can have many invoice lines and so on. So it's a kind of one to many or many to many relationships occurring into the type of databases, the network databases. This unit is relational database. We will discuss in detail the relational databases. However, the network databases, hierarchical databases, and object-oriented databases, they are itself can be a units of a particular course, or they can itself be a very much big topics of the study. For example, you could do the masters or PhD in the hierarchical databases, masters or PhD in the network databases, masters or PhD in the object-oriented databases, or particular course in the object-oriented databases. So we only will go into the detail for the relational databases. A relational database is a collection of data items organized as a set of formally described tables. So when you see a database in a table, that's a relational database from which a data can be accessed or reassembled in many different ways without having to reorganize the database tables. So once you have a database data in the relational database, then the arrangement of the data will remain same, but you can access the data in any form without affecting its structure. For example, you stored the random entries of the students. For example, the student roll number 3 came in. First, you entered the student into the database. Then roll number 1 came in and registered the system. Then in the random sequence, they joined or enrolled into they enrolled themselves into the system. If you wanted to access the list of all the students in the sorted form according to the roll number, then the data whatever you stored will remain as it is physically, but you will have an option to retrieve the data in any manner. That is the beautification of the database management system. A relational database is a set of tables containing data fitted into predefined categories. So, in the relational database, you will have to define a predefined category. For example, you have a student table, student roll number, student date of birth, student address, student courses that must be predefined. However, for example, if it is an object-oriented database, then you could create an object of the data, no matter whatever the structure is, whether it is predefined or not. But those type of object and type of the database management systems, like object-oriented database management systems, they allow you to create such a kind of the data architecture dynamically. But in the relational database, you are limited to the predefined categories. Each table, which is sometimes called a relation, contains one or more data categories in columns. Each row contains a unique instance of data for the categories defined by the columns. Most relational databases use the SQL data definition and query language. So here, this is the heading of the table. The attributes or columns, they can be unordered. The relation variable is the basically the table name. When you say R is a table, and when you say A1, A2, A3, they are the attributes or the columns. They can be unordered. There is no need to be ordered. And you can also call it heading. The body is the whole body, is basically the heading as well as the rows. And a row, this row is called basically the tuple in the mathematically representation. And this is also the unordered. No matter in which sequence you store the values, that doesn't matter. The matter, the retrieval of the data is depending on the database management system. It gives you the option to process the data without affecting its physical form. In the object-oriented model, like one object, for example, containing a maintenance report, which has date, activity code, route, daily production, equipment hours, labor, then this object could be created one more time from its object instance. Let us read here. An object-oriented database management system is a database management system in which information is represented in the form of object, is used in the object-oriented programming. Object data and databases are different from the relational database, which are table-oriented. Object relational databases are hybrid of both approaches. Let me try to give you an example first, that you don't have the particular category of the data known in advance. You can create an object of any table at any time. For example, if you wanted to create an object of maintenance report, then you could define its attributes like date, activity, route number, daily production, equipment, anything very much quickly. And when you create an instance of this object, for example, maintenance report, you are only feeding or storing the values. For example, date is 1/12/1, activity code is 24, route number is I-95, daily production 2.5. So you created an object of an entity, and instances are created against those objects. And in similar way, the activity code is basically related with here. So basically, in order to understand the object-oriented databases, you should have clear concepts of the object-oriented programming. Object-oriented programming is based on encapsulation, polymorphism, and inheritance. You exhibit these properties. You inherit the properties. So that will be beyond the scope of this unit. But in next units, we in the programming, or so in software engineering, we will get the chance to explain in detail. Now we come to the actual relational database. which is the Relational Database Management System, and now we are going to discuss the subunits like data models. Data models define how the logical structure of the database is modeled. Data models are fundamental entities to introduce abstraction in the database. Data models define how data is connected to each other and how they are processed and stored inside the system. So data has to be given a model. Every entity should have a model, and then the entities should have been represented with their relations as well. We discussed now the entity relationship model is based on an idea of real world entities and relationships among them. So data model explains you the logical structure of the database in the form of the entities, and entities have the relationship, and the entities are taken from the real world scenarios. While formulating the real world scenarios into the database model, the ER model creates entity set, relationship set, and general attributes and constants. So ER model is best used for the conceptual design of the database. ER model has three things. What are those three things? Entities, attributes, and relationships. An entity can have an attribute, an entity can have an attribute, and entities can have a relationship with another entity. It cannot be the situation that entity may have a relationship with the entity with the attribute. No, but attributes are contained into the entity, and entities have a relationship with the entities. So data models are the logical structure of the database which represent the entities, and the entities should have a relationship model which are based on the entities, relationships, and attributes. An entity in an entity relationship model is a real world entity having properties called attributes, and every attribute is defined by its set of values called domain. For example, in a school database, a student is considered as an entity. A student has various attributes like name, age, and class. So student is an entity, and attributes can be like name, age, and class. The relationship, logical association among the entities is called the relationship. The relationships are mapped with the entities in various ways, mapping cardinalities, defining the number of associations between two entities. For example, the student could have the enrolls into courses. For example, a student has a you know relationship with the fees. A student has a relationship with the the results, scorecard, and so on. So cardinalities include one to one, one to many, many to one, many to many. So relationships could have cardinalities, associations, which could be one to one to many to one, many to many. Now we define a relational model. Most popular data model in database management system, a relational model. It is more scientific model than others. The model is based on the first order predicate logic, and basically this is the another definition of this slide we discussed earlier. Like they have a relation, you call these attributes and columns. So this is the similar definition of the relational model. So we go to the next. Now database schema. A database schema is the skeleton structure that represents the logical view of the entire database. It defines how the data is organized and how the relations among them are associated. It formulates all the constraints that are to be applied on the data. A database schema defines its entities and the relationship among them. It contains a descriptive detail of the database, which can be depicted by the means of schema diagrams. It's the database designers who design the schema to help programmers understand the database and make it useful. So schema is basically the skeletal structure of the database. So when you are storing the data into the hard drive, that becomes the physical schema, and when you are storing the